It's one small step for man, one giant leap for mankind.
Is this a joke, or is this spam, or somebody, hoaxing me?
This is one small step for Saunders Machine Works / NYC-CNC, but one giant leap for the maker community.
There is no way we can make all of these parts. Thursday afternoon, and I got an email from Jen Schachter, and she was using a Gmail address, and the headline in the email was amazing. It's like Adam Savage, tested, Mythbusters, Smithsonian Air and Space, and this whole project. But then I thought, is this a joke, or is this spam, or somebody hoaxing me? And I started to read through it, and then I went to the Google Drive and started to look at the files, and I thought, oh my gosh, this is real.
I think my exact words were something like, yeah.
I mean, this is the absolute perfect project for us and the things that we're into as space and aerospace nerds. So
I pretty much grew up watching Mythbusters. I'm a huge Adam Savage fan. I watched Tested, so it was really exciting, really cool to be doing a project both with him and his team and the Smithsonian. I was really excited.
I opened the drive, and it had a link to the PDF prints, and there were dozens of parts, and they had to be done in about 30 days.
yeah, the deadline, especially considering the complexity of the huge assembly we had to build, we weren't totally sure we'd be able to pull it off. Kind of on the fence a little bit, like, can we actually do this?
It was a surprise that they asked us to do it that quickly.
Project Egress is a project being led by Adam Savage and the team at Tested, working with the Smithsonian National Air and Space Museum to celebrate the 50th anniversary of the Apollo 11 trip. Project Egress specifically is a group of other makers and collaborators working with Adam Savage to rebuild the Apollo 11 command module hatch door. So this is the iconic door on the iconic command module that Neil Armstrong, Buzz Aldrin, and Michael Collins flew in to the moon and back on the first moon trip. And the cool things about the door, number one, it's probably the most complicated door ever built in the history of mankind. And the hatch door is a really important part of the Apollo program, because tragically, it was the hatch door design and it being an inward opening design that resulted in the death of the 3 astronauts on the Apollo 1 plugs out test when the fire started in the cockpit and they couldn't get out. We are making the lever mechanism that is used as a ratchet style mechanism to actuate a series of cams throughout the perimeter of the door. So my understanding is the astronaut would have leaned over the top right shoulder and had some selector switches that could control how they sort of pumped or activated this to give, I assume, a huge amount of mechanical advantage to either open or close that hatch door. And the animations that Andrew Barth, the fellow who put together the CAD design and went through all the old prints from North American Aviation and others, it's an absolutely mesmerizing mechanical device.
Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
So that Thursday email I received from Jen Schachter mentioned that someone could stop by our shop tomorrow, Friday, and I thought, oh, they think we're in New York City, because no one's going to be able to just stop by Zanesville, Ohio with a few hours notice. And so sure enough, Andrew was driving on his way to the Smithsonian, was going to be passing right through Zanesville. So in a relatively short amount of time, we realized this would work. Ed and I had already gone through a lot of the fusion models. We had already started 3D printing stuff. And for me, really just starting to understand how this mechanism even worked. Unfortunately, I have a job I've got to get through, so I'll just work today, tomorrow, and maybe Sunday to get that finished. No big deal. And then I'll have a clear head. I can be my surgeon and focus on this. The guy's driving today from Illinois to the Smithsonian, which we are on the way, so he's stopping here in 4 hours. He shows up. Andrew's a younger fellow in college right now, and he shows up and he had two things in his trunk. He had his French horn and he had a testable, albeit not perfectly functional, jet engine that he had built. And he explained that his goal was by the age of 20 to build a testable jet engine. And he had all these ideas of ways he could make it better, and it was amazing. He had worked at a foundry before, so he had used a combination of machining and casting and just really creative skills on a limited budget with limited equipment to make an actual jet engine. Amazing. We went on a tour around the shop, and then we got to work. We ordered some pizzas, and we were here till, I don't know, late Friday night. It was awesome. So how did we get this done? Being totally honest, it felt really overwhelming. The number of parts and the fact that I knew many of them were going to be on our relatively new 5-axis machine. So there was the uncertainty of the number of parts, the complication of the parts. It's a new machine, buying tooling, buying materials. I think that's a great sort of lesson in life and as an entrepreneur is you break it down. So if you get a big project dumped on your plate, there's a balance of how to approach it. It's easy to just let yourself get overwhelmed and think about how difficult it may be or the amount of work or the struggles, but just break it down. Let yourself sleep on it, digest it, and reapproach it fresh, say the next morning. For us, what we had to do was quickly realize what is not possible. What are we actually physically not capable of doing? And for this project, if we hadn't had the 5-axis, there are a lot of parts that we would have just had to 3D print. It would have been way too time prohibitive and frankly costly to make them out of 6 or 7 or 8 setups with the requisite fixturing and soft jaws on a 3-axis. So if you're doing a project like this for fun or to pay it forward, or you're doing part of this as a job shop work for customer, be honest with yourself. What are your abilities? And if there's stuff you can't do you either say no, or do you work with another shop or partner to help get those parts made? And so we put all the prints out on a table. We started divvying them up within the team here. What stuff can be done on the Tormach? What stuff can be done on a 3-axis, 4-axis? And then we started looking at the 5-axis parts, and then you just dive in. And so Saturday morning, Andrew came back to the shop and we made the first part together. After we built the first few parts, we all kind of got into our stride and you kind of realized we can do this. And so it was actually kind of the perfect world of, okay, you need these to look good, you need them to be done correctly, but it let me have the chance to pour myself into piggybacking off of the fusion workflows and templates that I had already started to make, and it became fun. Like, it became an exciting project. I wanted to come in, I wanted to make the next part, I wanted to push myself, and we set up this table where we would lay the parts down on it as they came off, and so kind of watching that fill up and build up and that progress was really cool. Most of the 5-axis work was done on our 5th-axis vise with the serrated jaws that give you really good access to your part, and the parts are sort of self-fixtured, so you're left with a hat top or sacrificial part at the bottom. I know we use super glue to hold down some of the smaller and thinner parts. I know Ed used the 4th axis. We have a 3-jaw chuck that we use to hold the round parts on some of the milling or machining work. But for me, it was definitely the 5-axis, trying to look at how much reach you needed, how tall of a workpiece you needed, or how much extra material you wanted at the bottom, because it's that extra material at the bottom that would let you, say, do a roughing strategy and expose that sort of underside stuff that you could then flip over and do a relatively little amount of work to finish off the part.
My favorite part of it was the handle thingy that I made. It was a major part of the assembly, and it's gonna really stand out, so I wanted to make sure it looked really good, and it took a lot of time to make it match the original.
Probably the most fun part for me during this was the little linkage brackets, doing undercuts with the lollipop tool and getting the ball to fit in there just right. I use mainly the Tormach lathe and the VF2 to complete them.
The main output drive has 4 different sort of spines on it for 4 points of connections. And to me, that was the most fun part, because you think about that and there's all sorts of different ways you could hold that. But I wanted to do as much of the work in one operation, but because there was going to be at least one of those 4 points pointed sort of downward toward the vise, you knew that wouldn't be possible. So there would be a critical second operation. So I spent a fair amount of time kind of rotating that within Fusion, thinking about, do I hold it sort of directly up and down, or do I tilt it 30 degrees? And then knowing the B axis on your Haas, it can tip past 90 degrees, but you're still somewhat limited. I think it's 120 degrees, maybe 135. And so playing around on the software side of that, the simulation, the tool paths, and we did a lot of that 4th part in the first setup, except the interior parts that we couldn't get to. But what that meant was when I set it back up for that second and final operation, we had really good geometry to pick up our coordinate system off of with the Renishaw. It's a really cool looking part, really fun part on the 5-axis.
The most difficult part, oddly, I thought it would be super easy. We made all of the small anodized aluminum info plates that give information for what all of the switches and buttons and indicators on the handle do. I had lasered anodized aluminum in the past very easily, but for some reason the pre-anodized sheet we got from McMaster just did not want to laser, no matter what I threw at it. So it took a long time of fiddling with settings to get it to even try to engrave, and then I ended up having to fill it with some rub and buff to really make the wording stand out. But I'm glad that we made those info plates, because they really helped put it over the edge in looks and authenticity, making it feel like the real parts.
Alex was working on a really difficult part. He did some test parts, then he 3D printed it, then he figured out a fixture in the Tormach to do that part.
It's a piece of a hinge that needs a number 60 drill through it, which is 40 thousandths of an inch in diameter. And the part itself was only 80 thou thick.
Op 4, clip 2 for the Apollo 11 part, using a super tiny drill bit to drill half of the hole that goes down through the pin. This is also the only one we have, so I hope it doesn't break.
The problem originally was we didn't have a spot drill that could work, and because we needed this done so quickly, we needed to put in a McMaster order, and it actually turned out they didn't have a spot drill in the diameter we wanted. What ended up happening was Ed goes, "Oh, you know we've got a bunch of 1/8 inch spot drills in a drawer somewhere," and I used one of those drills to spot the hole, and then we were just fine. Using a drill that was stuck out as long as it was, being as skinny as it was, and trying to get that hole on center took forever, and I made the part 5 times in total.
The handle itself is 2 parts. One part of it we did on the 4th axis, but then the part that the handle itself mounts into is a pretty complicated part. So you had some really long reach areas, some tight radiuses, a difficult part to program, a difficult part to work hold, and I only had one piece of material on hand. It was a larger part, so you kind of had that additional pressure of how do you try to get this done and either be able to fix any mistakes or foresee any mistakes. I would machine a few operations and then kind of reevaluate and adjust. It wasn't kind of a you finished it and then just walked up and hit go. We did some parts that have split clamps on them, and I'd never used a carbide slitting saw before, so we had to buy one, which I wanted to do anyways, but then test it out, get up to speed on the speeds and feeds for it, and run it. And the first time I ran it, we did it on a part that ended up being a good part. And that's awesome.
Most difficult part was probably the little round thin disc. I think it was some sort of cover. I believe I used super glue to hold it down.
how did we keep the shop running when we had to make all of these parts? The honest answer is it was a balance of slowing down. We've actually tried to model our business around this idea that we run, say, things like our fixture plates and mod vices and let those kind of go on autopilot so that that frees you up to do other things. As we grow and get more machines, that'll let us run concurrent jobs or concurrent, say, fixture plates and so forth. But what that meant was, somebody like Jared or Ed would set something up and let it run, and then you've got 20 minutes or 30 minutes to go kind of play or program or test or make another part.
That handle that I like so much, the fluting. Inside the flutes is black. I initially tried, I knew I was making a mistake as I was doing it, tried using Rust-Oleum to fill those in, and then the idea would be I would sand off the high spots, leaving the black in the flutes. But Rust-Oleum never really tends to dry, so I had to strip all that back off, re-powder coat it like I should have done from the get-go, and from that point it ended up looking perfect. But that little screw up, typical.
Mistakes? I broke a tap off in a part. I think I forgot to measure the tool height because I spent 20 minutes trying to figure out why I broke the tap off, because we don't break taps normally. And then I ended up just rerunning it and on a test part, and it worked fine. So I gotta think I just had the wrong drill height. And then one other part, we had a gouge occur. I just didn't anticipate it, the way a tool hit a surface. And I thought about repairing it, and it was a relatively small piece of material. And I realized, no, I would much rather just remake this part from scratch. And that's actually the really fun thing about the 5-axis machine, is that on that particular part, I'd already proven out all of the program up to that point, and we had all the tools set up. So for me to go through all that work again was really no big deal. I put a new piece of material in, posted the program up to that operation, waited 20 minutes, and you were able to kind of undo that mistake and get a chance on a new part. That's really nice.
We copy you down, Eagle.
Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
We've landed on the moon.
Literally last 5-axis mode. It's done. This is really a dream to think that our parts are going to be shown in the Smithsonian, let alone next to the real Apollo 11 command module. I mean, that's crazy. I went to Air and Space this past Christmas with my wife and 2 kids, and my son loves airplanes, and we spent a ton of time. I mean, it's a great museum. I think everyone would love it. And I've loved the Apollo program now for a number of years as an adult, watching the classic movies that everybody knows, but then also the HBO series From the Earth to the Moon, and reading all the nuances on the Saturn V and on the command module and the lunar module, and how Grumman built them and North American Aviation built them. And it's just, to me, this amazing overall project. It's really surreal to think that they actually did it and pulled it off so successfully. And so walking through the Air and Space Museum, to think that we would ever be able to make a part that went into that museum, period, would be amazing, let alone to be able to do so in a manner that's actually a lot more public, in the sense that we get to show these parts off, talk about it, and all of the makers that have contributed to Egress get to have their names listed, which is really just, for me, I get to take my wife and kids to the museum, and we get to look at this and see it, and that's cool.
I'm proud to have had a hand in this project, something that's going to reach and inspire children and people of all ages who come to see it. And I was thrilled to work with the group of makers that also had a hand in this collaborative project. People I've looked up to and admired for as long as I can remember have made pieces that are going to be right there next to the ones that we made.
Hundreds of thousands of people are going to be seeing that over the course of however long it's up, and just knowing that I had a hand in it, it's pretty neat.
It's really cool, especially for me, being only 18 and I just graduated from high school. Working here and doing cool projects like that is absolutely jaw-dropping for me.
Honestly, I'm incredibly happy and frankly proud of what we all put together and did and pulled off here. I think it's awesome. Like, I feel very, very good about what we're sending down to the museum. I give a shout out to my wife. I, for years, worked a lot of nights and weekends, and luckily don't do that as much anymore. But for the past month, I spent a lot of early mornings here and later nights, and I loved it. Don't get me wrong, I loved it. And it was really rewarding because the project gained momentum. Everyone here was super excited about it. I want to say thank you to Andrew Barth. He was a fan of our channel. He's the one that suggested to the team at Savage Industries to put us on this list, and I'm flattered and honored that he did so, and I'm grateful that he did so, because I am so happy and proud to be part of this project and to make the parts that we made. But also the list of other folks that are on this is just absolutely awesome, and I cannot wait to go down to the Air and Space Museum in a few weeks and see Andrew, Jen, and Adam assemble this whole hatch door on stage, and then to see that 50th anniversary Apollo exhibit. Really cool. Hope you folks learned something. Hope you enjoyed. We're gonna have some part-specific videos coming out in the coming weeks showing the CAD, the CAM, the fixturing, the tooling. Some of these parts really kicked our butt. Some of them we really learned a lot on, and I wanna share that with you guys. And again, thanks to everyone else that we've got to meet and collaborate with on this project. If you can make it to Washington, D.C., I'm gonna be there with some other folks from our shop. Tom Lipton's coming, and I hope even more, for the event on July 18th at the National Air and Space Museum. Otherwise, folks, take care. See you soon.